the effects dependencies from a generic like colorless standpoint. So could a compiler extract dependency from a single effect function? In a shallow sense, yes. React's compiler does exactly that. So does Felt3. But the compiler-based extraction only sees what's in scope. It can't see the whole graph. If your sources are functions that call signals rather than signals themselves, the compiler has no way to know whether those functions are pure or whether they hide side effects. This is exactly why Svelte5 moved to ruins. Compiler time dependency capture hit a hard limit. It couldn't track sources that weren't syntactically visible. What I mean is, if you've ever done something like this in Svelte, you'll know what I'm talking about. This in Svelte 4, this is like a reactive value. So if you put doubled equals count times 2, it will update. But if you call a function that does the count times 2 out here, Svelte couldn't see it. Svelte doesn't, like React would move like, compiler would like move get double count out. Yeah, let me make this a little bit, let me use React language and or solid language and make this a little bit more visible for everyone so you can understand. So let's make this solid now. So we want count set count. Okay. Okay. So equals create signal. Okay. So we're using solid syntax. And then this here is a memo, but I'm going to use an effect here. I'm actually going to use a split effect for, or like a React style effect. How do I want to do this? It's fine. I will use split effect here. Like I'll use the new solid APIs for the sake of trying to show this. There's only one dependency, so I'm going to still destructure it for the sake of doing this. Okay, cool. So console.log effect, okay, or count. Now, I guess what I should do is what I should do is actually write what you would think you would write instead. So let's go here. Let's pretend our effects like this. So this is in, and this is compiler out, okay? So the difference with Svelte or Solid, and it's kind of important here, Svelte doesn't have this, right? And React doesn't have this. So when they look and extract the dependencies here, their first thing would be you'd have to have a special processing to unwrap signals, right? Because anything that you saw here that was closed over, you would have to know like how to handle it, right? But the question is, what should it handle? Because sorry, let's change this to get double count for a second. So this is a function. In React, what you would do, generally speaking, is you'd extract the function, right? And then you'd go, okay, so get double count. And then you could call get double count here. This doesn't help us because you're still calling the function in the wrong spot, right? Like, the reason this works in React is because the component reruns. So every time the component reruns, this reference will change. So like when you update count, you get a new get double count function, which means that this will invalidate and then you will call your function. But that's not good for us on a reactive side, because we actually want to track the reactive reads, and this function never gets recreated again. So what's your options? Well, you could not call the function here, essentially, and like do something kind of smart where you're like, okay, I see the I see the function, I should call it here. But the problem with this is, how do you determine it? Like in something like Svelte, you can see that the reactive values are local values, I think. But what if it's coming from somewhere else? Like what if this is actually a function? You don't know if this function is get double count, which is what we want to do, or if this function is do crazy side effect. What's different between these two functions that tells us which one should go here and which one should go here? If it's just a symbol like React does, it doesn't matter because you're going to do all the work here anyways. But if we have these two functions and we treat them the same because they're function calls, also not good. What if you do create effect? I think I already showed this, that we give you a warning. You might have missed that part of the stream. If you do this, maybe it should throw or be a little stronger. But reactive value read in the effect callback will not update. Move it to the tracking scope, either JSX, a memo, or an effects compute function, which is the first function. So we actually tell you you're doing something wrong if you do this. So anyway, my key point here is, unless everything is kind of treated top level, like we don't, like the compiler, like this is the huge difference. React reruns, so when it looks at the dependency arrays, they're not deep. It doesn't really care. It just gets a symbol and goes, okay, if it's closed over, like basically there's something smart it can do here. It knows it can't read local state if it's not in the same scope. If the function's global, so it like doesn't change. Like the only way count gets into double count is if it's in this below this component scope, which means that when you rerun the component, you're going to get a new function, right? This is why like what use callback does, but it's kind of like funny in the sense that like you can invalidate, like if in React, if you want to memoize you memoize functions, like you might invalidate this function whenever count changes, which is like makes sense, but is completely bonkers from a signals perspective, like a single run perspective. Like you would never memoize a function. Like why would you create a new function just because count changes? You just read count. So in a sense, a simple system like React, which reruns components, or like Svelte 3, which reruns components, could get away with this. But as soon as you have deep, discoverable reactivity, you can't differentiate between. You have two choices. You have to force this to only grab actual known signals, so you kill composition, or you just can't do it. Like you risk leaking side effects. Yeah, well, and the funny thing is, the way we think is really weird. Like, I had guys from the React core team like arguing with me about this stuff, and they're like, "Well, how would you do this crazy case?" And they showed like this thing with function memoization. And I'm like, I never thought of memoizing the function. I just read the signal. Like they came up with a pretty good convoluted case, and my solve was so simple. And like because they were looking to try and solve it in a React way, and I'm just like, just the function's a stable reference. Like that's not what you should be invalidating on. You should be invalidating on the actual things that change, which actually made the code cleaner and smoother. I think it was I forget who I was debating it with. I think it might have even been Seb himself. My point is, from a pure like hoist the effect standpoint, React can do this, but we cannot, and the same reason why we cannot is what gives us that richness that we can do stuff like this, where we can deeply discover stuff. It doesn't have to be count. What if it's a proxy with properties and stuff? We're not looking for specific symbols that, so we don't have to look in a shallow scope. This is why runtime reactivity is so freaking powerful. I think I will stay with React. It gives me job security. So the React compiler, no, what I'm saying is the React compiler can't, and they probably won't. And Svelte already is solid system. I'm saying old Svelte was different, but Svelte realized that they couldn't actually solve this with a compiler, so they introduced runes. Or runes. They couldn't 100% solve it. The Svelte community was like very upset that they suddenly had the right state this, and they couldn't just do let count, for example. But this little bit of extra syntax gave Svelte enough that it could basically solve this problem. But Svelte isn't doing this. Svelte is doing it solid 1.0 style, where it just you write you write count. This is what Svelte 5 did. Svelte 5 took you writing this and instead outputs this, more or less. I mean, it doesn't use our syntax for destructuring under the hood. It probably just puts it on a thing, but it goes through and goes, okay, where's all the references to count? Okay, count is here. Make that a get. Where is this? This is already fine. Nothing special here. Yeah, and now there's no out here yet. Like, all Svelte's compiler is doing right now, for the most part, for the signal stuff, is literally looking for where your call site is, taking the special object there, and then finding that symbol and just turning them into gets or sets. Oh, confirm staying on React? That's funny. It's supposed to do the opposite. Oh no, sorry, confirm this. That it always the only way to stay sane. That was a joke. It's all good. So it's basically just a solid wrapper. Yeah, I mean, there are differences in stuff, and especially in the async solution. But like generally speaking, the move to Svelte 5 put us very much in line, and Vue Vapor for Vue as well. Like Vue already had signals, but the actual rendering mechanics are much closer. There's obviously differences and stuff. But like it. I would say that, I mean, and this surprised no one, I'd say that Svelte 5 is much closer to solid now, obviously, than Svelte 3 was to solid. Svelte 3 was basically, yeah, how do I frame this right? Because Svelte 3 was like React, but it's actually, like, Svelte 5 is more similar to solid than Svelte 3 was to React, but that comes as a surprise to no one. What probably comes to bigger surprise was that Svelte 3 was closer to React than it was to solid. That's probably the bigger surprise to people, like significantly closer to React than it was to solid. Okay. But my point is, in a pure sense, compiler can't solve this from the dependency. But if you attack this the way that Rich has, compiler can solve this, because what Rich did is a little bit smarter. So instead, if you recognize here that double count equals, sorry, const doesn't make sense anymore. Whatever, it doesn't matter. But if you realize that double count is like $ derived await count times 2. Some effective double count. What you can do is, like, I'm not going to say this is 100% how Svelte does it, but they can, first of all, they're not blocking your whole component necessarily. What they're doing is they're probably kind of doing something like async derived. Like they're probably eating your await. Remember to change it to a function, so you call the count. And then they're async derived. I believe they has the ability to block effects. So before, yeah, this one becomes a getter. So this becomes a getter. So essentially, although it has to do more than that, because how do they know that this dependency is on this dependency? Okay, let's see what spell outputs. Why guess? Why guess? We don't need to guess. Wait, we have count already. Let double count equals $ derived await. I'm just gonna do it sync. I'm hoping this still works. There's no name here anymore. I just want to see if this picks up on it. Oh, okay, yeah. Oh, it's even smarter than this. It actually looks for the okay. What if I had another one? It's that triple count. What if I do something in the middle that's completely unrelated? I'm just really curious. Count 2. Let's make count 3. Whatever, it doesn't matter. Oh, interesting. It tries to keep top level semantics through the async. See how below is above is fine. Let's do below. So count. Let's make this 3 and let's make this 2. Okay. So everything above the first await is not part of it, but then it basically has a special runner to process these things and guards the asyncness of it, right? Interesting. Okay, just aside. The details aren't here too important, but the important thing to understand here is that these now are kind of tied together. This is like the consumption point is in the components essentially, which is frees you up so that the rest of this can act independently. You know what I mean? Like, but there is definitely like this is like using use in a sense at the component level, which I think is what Rich is saying here. Push based reactivity for async, push pull for everything else. Obviously, there are trade offs everywhere, and unnecessary selection jobs, but async forces effect splitting and DX downgrade the turn isn't true. Yeah, and he's right about that. Well, he's right. He's right about forces effect splitting. DX downgrade is arguable. I could argue his approach is a DX downgrade. Actually, we're going to illustrate why it is. but maybe not quite yet. We'll get to that in a minute. But I think I think the general idea still holds, right? In a sense, a compiler can solve this if you look for the awaits and hoist the awaits. It can't solve this at a signals level. Is my point. Um, so does this mean we're doomed to mimic React? No, not at all. This isn't copying React. It's acknowledging the same fundamental truth, right? Async forces commit isolation. Async forces effect splitting. Vue's had the split in its watchers for years. These aren't reactisms, you know, like they're invariants of any system that wants to preserve consistency in the presence of async, right? So like, in my opinion, this doesn't erase the advantages of signals so much, right? Like we are still surgical, you know, we don't re-render. It's only the effects that require the separation, right? That's a difference thing. Like React, because the render model, they need the depths everywhere. They have a compiler that kind of compile it away. So, but like it's important that I think we acknowledge this. Anyways, um, to kind of finish out this article, I think there's some important truths. I didn't really get into why async forces consistent snapshot, but that was what I was trying to talk about earlier when I was talking about like the A, then B, then C. Like you kind of have to, you want your effects to all flush at the same time to be consistent. So when you have all of these aspects where you know, it doesn't, I guess it's wrong to say async forces effect splitting isn't correct. Async forces knowing the dependencies ahead of effects running, but it does force commit isolation, effects ahead, and async and a consistent snapshot. These things are true, right? So I thank you, Rich, for help like clarifying a little bit that effect splitting isn't an inevitability of the problem space. It's an inevitability that comes with being colorless. I think the more interesting argument and where we can go from here is kind of showing that you can't avoid going colorless to a certain degree, so you might as well embrace it. Is essentially where my next argument is going. But the whole thing is I don't think this suddenly makes us react if that's what people are scared of. I did get a lot of feedback about this, but we should recognize, like I've always said, React gets a lot of things right for really good reasons. So like we should never be too quick to judge React's design decisions. I would say you can judge their implementation stuff to cows come home, but almost everything they do from like an API service side, from like a conceptual side, is pretty infallible from like a theoretical standpoint. So I mean, take it as it is. I thought this was a pretty pro React article, because I'm basically admitting that signals libraries shouldn't hide or pretend or lie anymore. You know, this is a big step. Um, I think this is important. I I don't think this article really hit. I think it's well written. I think it's to the point. I think it shows great examples. But I'm not. I I don't think people understand yet just how important this is and the conclusions from this are. Um, but I mean, that's like most of my stuff, right? React's stale closures is arguably a feature in async because it gives you perfect consistent snapshot. Yes, and that is, sorry, where was it here? That's what this did. Sorry, not count, because we err on that, or we warn on that. This gives us our consistent snapshot back again. Because you don't read the count here, this essentially is what returns, gives us that same guarantee. I like the way you're phrasing that here, because that is the key here. This count is in the past. You know, I had this problem when I originally set up. If we actually go back full circle to the original article that I did on consistency here, looking at this 3 years later when I first started thinking about it, I was really struggling with this batch behavior thing because like I really wanted to be consistent. At this point, when you're outside of batches, solid worked like 1, 2, 2, 2, like the way that I showed. But when you're inside batches, it worked like React. So as soon as someone wrapped something in a batch, suddenly state updates weren't visible, and it meant that our code worked in two different modes. So if you wrote a function that did some stuff and then someone read it under batch, it'd be completely broken. And that was the biggest bug. I just had to choose a direction, essentially. Like it didn't matter that much, I guess, in hindsight, which direction I chose. I think there's importance for correctness and stuff, obviously. But in a sync world, given the capabilities of signals, it actually didn't matter. I could go the React way and be consistent, or I could go the Vue way and be consistent enough. I just had to choose a direction because having two different modes in solid was a death sentence for doing stuff in composability. The fact that batch completely changed how your code worked really messed with people. And in solid 1.0, we run all the effects in a batch function. That was intentional because you don't want like in the middle of the effects run to like start triggering other stuff. You want to let the effects run all the way through and then do your thing. If you do them in the middle, like the next effect will see different state from the previous effect if people are setting signals. And a bunch of people tried to argue that was okay, and they won because that's where Solid 1.0 ended up. They're like, what's the worst case happen? We just queue another effect on the back and we just eventually get there. But it meant that effects could kind of like run multiple times within a single cycle, depending on the order that signals set. And I never liked that, but I kind of accepted it here. But because in the original batch behavior, if you called set count in an effect, you couldn't see it on the next line. You couldn't see it in the next effect. You had to wait, like React does, until all the effects ran. So if you're in your event handlers, stuff happened immediately. But when you're in effects callbacks, they would be stay in the past. And I love that because you had a consistent snapshot. Effects run consistently. They run to finish. They're always like run once. Everything was good. People in our community argued so strongly about it because they were used to things like MobX, and they're like, look, it'll be good enough. Reactivity will settle. And I'm like, yeah, but it's like you get in weird ordering states and all this stuff, and the only reason I eventually agreed to make this change in Solid 1.5 was because of the two mode things being bad. I had to choose a side, and if I wasn't going to choose React side because everyone hated it, I'm going to choose Vue's side, right? Which is what I did. I always knew that that was not a great decision. That React was consistent and Solid was consistent. Going to Vue's approach was a compromise. But it was a reasonable compromise. One that in a sync world we can live in. But in an async world, given that we can't live in it, yeah, like look what I wrote here. So honestly, this all sucks. Enough that I feel the need to be aware of batching behavior. And with this awareness, I'm compelled to offer consistent default that feels the sanest thing to do. For many of you, this is probably unsurprising. I'm the author of Solid.js, so why wouldn't I say that? Solid's eager updates work well with its rendering model and are completely implemented by opt-in batching. But the real revelation to me was just how much my opinion changed in the last couple of years. When I first saw this problem designing Marco 6, I was all in on Vue's batched reactivity. Being compiled syntax, having explicit opt-in felt out of place, and mutation not updating is awkward. However, I definitely would have put Svelte's approach as my least favorite. And right? But now I'm not nearly as certain. Working in Solid, which embraces explicit syntax, I have all the tools at my disposal. If batching is opt-in, and if I'm going to give up consistency for intuitive behavior and support mutation, I want predictability at least. And that Svelte's too simple model makes a lot of sense. So I actually couldn't, like, even then I was actually trying to argue for Svelte's model, just to, as I said, to avoid React's model. So coming from natural batching, I don't know if there's a lesson here. I can't fault anyone for coming to different conclusions. These tricky problems are why I love this work so much. Skeptics might point out Solid has all the update models in it, and they'd be kind of right. I don't know. Can't beat them, join them. Yeah. yeah, when I look at this whole old article from 2022 in hindsight, I already knew what the answer was. I just didn't want to admit it to myself. I think we all kind of know what the answer is. Okay, so let's continue here. No DX standard. Let's talk about the colored versus colorless, because I think this is important. Because let's continue this discussion a little bit. So there's some potential in solver we could get rid of split effects again, and the whole community has migrated to coexist with them. No, that's not happening. Not too late to change course. Yeah, I love how you guys make it sound like it's actually a bad thing when like split effects are so beneficial when you consider all the aspects. Yeah, and the create async API is not that, because create async for us is not where the read happens. It's not where the block happens. It's okay. Yeah. So let's start. Let's just scour all this for a second. Let's see if I can pull this out and get somewhere where we want to be. Okay. So what's the shape of async? There's 3 points when you're dealing with async. The first point is where the like. Let's pretend we're dealing with fetching, but like the first point in the measure is like creation, i.e. like do the fetch, right? The second point in async in a JavaScript framework or like framework is a consumption point. Framework absorbs the promise. The third point is read, where the value is actually used. Okay. These are 3 fundamental stages in when we're dealing with async in JavaScript frameworks. And I think it's important to look at it like this, because even if you're trying to like compare different solutions, you're gonna find you're still working around in this space. So can I give some concrete examples of these APIs, perhaps, right? I already did with fetch, right? So what's this one like? Fetch user.id, right? Concrete example. Consumption. Actually, you know what? Let's do this a different way. Let me like go like, okay, how does this look like in React? Fetch user ID. Okay. Let's do props. Fetch user props.user ID. Okay. Sounds good. 2. Use. So this is promise, right? I'm going to call it p user, right? 2 is use p user. And 3 is actually, let's get narrower than that. 3 is h1 user.name. Okay. No, the whole point of the stream is that this is basically science. Even when we disagree a bit on the implementation, all that, there is a certain science to this. You can like avoid the problem, but it's like it's there. Once you discover it, you can't unsee it. Okay, so this is an example of how this looks in React. React 19, actually, if we want to be really specific. let's do the same for Svelte 5. First one is the same. Svelte doesn't use a props object, right? Or is it like $ props now? I can't remember. Seems like everything is a $. Let's pretend that's right. But don't get me wrong, you can combine these. It's just it's important that we see the separation. Okay. And then this is the same, okay? Why is Solid 2.0 different? You might be asking. Technically, you can do this, but in Solid 2.0, it's a little bit different. And I have to fix the Svelte version in a minute because this isn't reactive, so it's a little bit. I'll get to why this is important in a second. Solid 2.0, the design is that creation and consumption happen at the same place. Sorry, creation happens here, sorry, and consumption and read happen in the same place. Okay? Which is a little bit different here. See, React doesn't care because React re-renders the components. So there's actually a problem here with React because our first problem here is actually it's probably fine if the suspense is below. Yeah, let's pretend the suspense is below. Let's pretend this use is not in the same component. Okay, just makes my life a lot easier. React gets a new user ID, fetches a new user, passes the promise through to where the use is, which is where it actually uses it, and then somewhere below that actually uses the user. Svelte, if we wanted to react to the user ID updating, we actually have to change this equation a little bit. We actually have to, if you understand the problem, right? Because props ID has to be reactive. So we actually have to do this, if you think about it. I mean, we could defer this await as well. Like we can keep both of them, perhaps. But I think it's more, let me change the structuring here. Let me zoom out a little bit and kind of get to where I'm trying to get to. Because if you want it to listen to this, it has to be part of a reactive expression. So essentially, what Svelte does is it puts 1 and 2 here, and then does 3 here. It's a very, like, these two things look the same, but they're different. Does that make sense? Do you guys following? Technically speaking, I can still separate 1 and 2 with Svelte if I separate them across like different boundaries. But like what I could do is I could. It's hard because the fetch is based on the reactive prop, right? So it needs to be derived, but I don't need to await it yet. So I guess it's possible. I think it's possible in Svelte for me to change this. Sorry, this one's user, to change this to p user equals $ derived. Yeah, maybe this is better. Is this better? and then await P user. Like, yeah, I think this is probably the most accurate. Yeah, okay, sorry. Yeah, there we go. The reason I didn't put the function is because like under the hood, this is a function too. Like in Svelte, it doesn't really matter. Like, yeah, but if it's reactive, you have to listen to it in a reactive scope, I think. Like they might have some sugar syntax here that I don't have to wrap it in a derived. So like I like, but conceptually, what I'm trying to point out here is the await is the consumption point for them. You're kind of tempted to just put the await here, but if you put the await here, you fetch too high, or you block too high, the consumption point, right? So like you kind of want to like I could be wrong about the exact syntax, but mechanically this is the consumption the same way it uses the consumption here. And in solid, the consumption is actually here. Like this is very on certain way this makes these things similar, like the mechanics the way we hold is similar, but this makes things very different. And it's important for me to point this out because we were talking about dx, right? You could argue, as I said, that Svelte and Solid can have the same dx essentially, like when you squint at it, by essentially moving this to here, right? This is what I was doing earlier. Now, if we're like, sorry, let's move my thing a little bit this way. Now, if we're squinting, these two are the same, right? If I put them on top of each other, like create memo, fetch something, derived, fetch something, username. Like these are the same. And the same way I was saying that these are the same, right? But there's a huge consequence of this. DX wise, you want to do this, in my opinion. This is where you're tempted to do. You're just like, okay, just freaking await the thing derived, get my signal. This is what you want to do. But this splitting them is actually better for performance. You mechanically you want to do this. You want to be able to, because in terms of where these points go is this can be used in multiple places, right? P user. So let's talk some truths here. Actually, first let me edit this one. It's saying like phases of async. Is it phases? Steps? Stages? Phases of async in JS framework. Okay. All right. Cool. And then we have this thing. And then what I want to put on here is there's some other rules around this stuff here. I can implement it here. You want to do this as high as possible. Not as high as possible, but as high as needed. What I mean by that is if you use the user in like 20 components and then a whole tree, you don't want to duplicate this necessarily. So generally what you're going to do, I mean, there's caching solutions and stuff, but generally you're going to fetch as high. You might put in a global store. You might put in a store that's happening not Redux, but you know what I mean. You Zustand, whatever. You're going to do this as high as needed up in the hierarchy. We might even be global, maybe even global. I mean, I don't need to put that note. You get it what I'm getting at. Consumption. You want this as low as possible. You don't want to block unnecessarily. You don't want to cause waterfalls. You want to be able to like have the framework do as much stuff independently without getting blocked by async. And then here, well, that is so. I mean, we can another way we can read this is low as possible is the read. Conceptually, when you're designing the system, you want to be able to fetch as high as needed, but consume where you read. That's the fundamental thing here, because if you consume too high, you can already see it, you block, right? You're like if you're sitting there in your component, I don't need to pull up the Svelte example with the run. I don't know how blocking that is or how eager it is, but like they had to structure their whole async around it. If this is why I don't like async components in general. Like forget this for a second. If someone was like, I think my framework should have async components, async component, async function, component one, right? Lovely. Okay. Look at my awesome framework. Const user equals await fetch user. So simple to write like this. Const user posts equals await fetch user posts. Lovely. And actually, let's put some props in here. So let's go props.user ID. Props.user ID. It does not get easier than this. Like, look at the DX. And then I just like return, a couple components. This is lovely DX. I can go user. See this, just self-close it. Because we'll pass user here. And you might be like, well, why did you even do it here? Well, the reason is because user posts component actually needs both. So, we needed both the user. I could have put the posts fetched below, but as you'll see in a second, it actually doesn't make any difference. Lovely. Good DX. Yeah, which is good. I that helps a bit, at least on a shallow level. It depends on how lazily the discovery works. But as I said, I don't think this actually changes the math all that much. It does exist earlier. Sorry, going back to that example, but let me get to the gist of the problem. I mean, actually, chat. If you're still awake, what is wrong with my picture? Why is this wonderful DX about the worst thing you could possibly do? Yeah, waterfalls. Yeah, like you're waiting for user to wait for user posts. And they don't need the waterfall because they actually depend on the same thing. You don't need user to get user posts. And I'm not even like, I'm actually preventing my ability to even show anything too. The waterfall is the obvious one, but async component makes it even worse because I can't even show a fallback unless it's like above it. I can't proceed further than this. But waterfalls are great. It looks like RSCs. Yeah, about that. Well, the smart person will come in and say like, well, solve the waterfall. God, not hard, Ryan. Seriously, you couldn't come up with this. Not hard. See, our perfect DX is saved. Yeah, I'm completely joking. Um, Promise all doesn't solve your problem. I mean, it is a solution to the problem. Now they're not waterfalling, but you still have a bigger problem. It's still as slow as the slowest fetch. Now, it's quite possible that this doesn't matter. But look, user doesn't need user posts, so why the hell should user wait for user posts? Like promise all is not the solution. When people pull out promise all in their components, like when that's their solution, you know you're in the wrong model. Like you're doing the wrong thing. Promise all is not the solution to this, nor is like on promise settled or any like the interesting like split promise race or what. No. Um, just use caching. Yeah, I mean that helps with the re-render problem with React, but that or just use caching from the perspective of like never fetch anything and have it all be cached. But what I'm trying to get at here is this is why you don't want to consume or block high. Now, it doesn't have to be a definitive block, to be fair. Like there's ways around this scenario, right? Like this is the definitive block. Um, let's not definitive block. Right. Actually, let's not definitive block. Now, or maybe I forget how this works. Where does the use go? Can I promise all with a use? It doesn't matter. Maybe I'll get rid of the promise all. Yeah, let's get rid of the promise all. Okay, so now I've invented my own keyword, so I don't definitively block. Right? This is better. Definitely better. I also have to have a caching system or some kind of concern with that built in now because like I actually have a problem here because if my component reruns and it fetches user again, I'm actually in trouble. So uh, using like this doesn't really work well in a rerun system. This is kind of what forced React's hand here. It's like why React is so you need to separate this. React like says like you basically should separate the creation from consumption. You like, basically have to, which is good because you actually do want them. These actually should live in two different places. The challenge is because of shared state, it's difficult to make this as low as possible. Once you start forking, if you want to derive it, I mean, don't get me wrong. Like, go ahead. We can make a component tree where, like, we have we pass something all the way through, like, and like if we want to derive something, we could use promise chains, right? You can always like not this one, this one. Going back to our lovely example here, right? We have to pull this out now. So realistically, this is our user section component. So we could go like props dot user p user promise, and then we can go somewhere up here. We'll make another thing like let's call it app for now, and I'm going to assume the app knows about the ID here from its props. I mean, it could be like I don't even know what to call this. It's not even an app. It's like user page has the routing information, and then we can do something like this, and then make user promise. I mean, this isn't an actual real app. And props dot user posts promise, right? And then we can have user posts promise equals fetch user post. I should have just copied this before. And then we can, this gives us a good place to put our suspense boundary, by the way. Why not? And then now we can make our user section take user promise props. Or and then we just go user promise equals, and we can also do user. You know what the problem with this is? We should actually make this user. I'll continue with this direction for a second, but I don't like this for a reason. I'll get to it in a minute. We can make this user posts promise. The reason I don't like this is because, as it turns out, while this works, our user section actually also works in a place where the data is available and doesn't actually need to be a promise, right? Because like right now, our prop types are kind of like, what are they? User promise is what? Promise of user, let's say. And user posts promise is a promise of user posts array, probably. And then that will work. And actually, while we're at this, let's fill out this example a little better. Let's user posts. We don't actually. We can move this use down here, right? Because we don't actually need it up there. So let's move it here. Sorry, that's not what it is. And we can go props dot user posts promise, because we actually have to. Yeah, so our prop type here is we actually want user posts promise, which is a promise of user. Sorry, this is just, I know there's a lot of plumbing here. I just have to make sure that all my prop types coming all the way down are the right ones, because and it's also takes a user which is not a promise, it's just type user, right? Okay, cool. I could make it, actually, you know what though? I could make it I mean, for now we'll just do this, and then that roughly looks right? Yeah. We should make it actually support both. So we could make it user or a promise of user in case, right? And then this could be user, and then our local user could Can you use on a synchronous user? Probably. Probably. They probably support that. I don't know. Someone React will know user a little better. So then we can make it user posts or array or promise of user post array. And then we should do that down here too. Because now we can go either way now. Which, if we go either way, we actually should probably bring this down here too and call the use here just in case. Right. And then, because we might use user post somewhere else. So I really want to make sure we're capturing the DX here, okay? Really want to make sure we're capturing the awesome DX here. Yeah, okay. So yeah, this is cool because this supports both and we can read them both here. And then this is fine. We start it here, we pass them here. So these are actually sort of type user. Yeah, that's good. Okay. And then so this might be a type user posts. So it can be a promise or not a promise. And then, I mean, there is, I guess to be fair, now that we do this, we can actually remove this, right? Because now our user could, we don't need the block there because we can defer the blocking here. Right? And now, yeah, exactly. And then our props will be of type user I think I got it. Okay. This is not bad. I would argue that at some point, like we this is still simple. There's no conditional logic. There's no there's no like if there's further conditional logic, then the use might we can get the use pretty far down, right? If we want to. I mean, it's not into the template level here, although I think you can use using the template in React, but we'd have to worry about where our suspense boundaries are. Like I think probably in this case, we'd probably want, because we have to either use a post here, we probably want to wrap this one in a suspense boundary too to make it a separate boundary. Right? Wrap that one in a suspense boundary too. Yeah, I like that. Yeah, we can make maybe promise is nice. Yeah, let's go through here. You know where I'm going with this, Robbie. No, the maybe promise is T or promise T. I like that. Maybe promise. Yeah. Nice. All right. Okay, cool. And as I said, the proper solution Svelte 5 probably looks 90% the same as this. Oh, you're right. I'm missing the T. Okay. Yeah, I mean, to be fair, this level of prop drilling is not that bad. I made it seem really painful because I sit there and did all the promise. It's not just a prop drilling. I also have to actively consume the use in the places as well. And I mean, it would have been a fun exercise, I suppose, if we had started with the system being synchronous and then added the promise to it and then basically went through and rewrote all the components. Because the the difference with a colorless system is I could make the change right here and not touch any of these other components and they'd all work. Right? It would be just as bad with synchronous. You're right. But if it was, but changing from sync to async is it involves touching every single touch point, and then actually the use is actually and the awaits are actually additional overhead over synchronous too. Well, I mean, we like the reason that I'm trying to show this off here is this is mechanically what you want this separation here mechanically, but how tempted when you have a run one component are you going to be just to do this? Because picture, I did this in React syntax, but picture if you like you could picture if your component structure wasn't like this. All these maybe promises weren't there, right? Right? Right. So I'm going to remove all the maybe promises for a minute. And you didn't have any of these uses either. Okay. Okay. Let's look at this a little bit more practically, right? And you're just starting here and you have this conceptually, right? And someone came in and were like, okay, well, this is simple. We have an async primitive for this. So all you have to do is do this. User, and then you go, okay, I'm going to do derived use. I'm going to use like a solid like syntax here, but I'm going to do derived await fetch user, or let's call it memo. Doesn't really matter. Memo await fetch user. Ta-da! Guess what? This is like a reactive library, so we don't need the like, you know, like this should have been a await or some cached out. It doesn't really matter, but so we know that we can read this underneath here. So technically, I didn't need to change. Sorry, user posts. I didn't need to change any of the components. I just wrapped it in an async derived at the source, and everything works. And you're like, sweet. Except there's a problem actually. The suspense boundary doesn't go here. Actually, the suspense boundary goes out here now. So you're like, okay, whatever. I'm just gonna. I mean, this is not hard. Return suspense. I know this is a weird hybrid, weird component system, but I'm just like, this is not real. This is not svelte. This is not solid. This is just user page, and we're going to pass in user ID, whatever. Doesn't matter. So what did I manage to do here? I saw that I had some async, and I was like, sweet. All I have to do is create a boundary around my async, and then just async derive it, and everything I have automatically just works. That's great. That's great DX. Um, I'm missing a comma somewhere. I don't feel like trying to figure out where I'm missing that comma though. Because because it's really easy. I can just take my whole app that did a bunch of stuff, right? I probably didn't even have this suspense component down here either yet. No. And I I can basically just add some async fetching up high where I was doing my fetching, would do my fetching, and then wrap it in a boundary and call it a day. No, yeah, that's not my only point here. My actual point is the DX that you want is solids DX, but that's not what you get. This, if you give people the ability to do this, they will do this because this is what you would do in solid, right? The difference between this and solid is that this blocks here, not down at the leaves. The solution, it works, but it blocks at the wrong place. This is great developer experience. This is easy. Unlike React, you don't have to worry about the components rerunning per se, like in whatever system this looks like. You know, you just make it an async memo or async derived value, and you just wipe your hands clean of it. The rest of the system isn't aware of the asynchronicity. It all loads and it all works. This is the path of least resistance. It's also the path of least performance. People will gravitate towards doing exactly this. I mean, wouldn't you? You just saw that what we had to do. We had to go through, update all the props, add all the U's or weights all the way down through, go through every single component in this tree and do this migration. Or we could just freaking fetch it at the top so that we get rid of our waterfalls. Guess what? This maybe this is a route loader. You know, like this is, you know, we already do this. And then basically, like, look, there's no waterfalls here from a data fetching standpoint. But I mean, from a UI standpoint, there are. Like if you were streaming, you're not getting what you want out of it. This is you are naturally going to go this direction, right? Like, and this is what I'm getting at. React, the confusion was people wanted to put fetch user directly in use, right? You want to put await fetch user in derived. Yes. Now, the height isn't determined. Sorry, which feels, even though the complexity behind the scenes, the API service feels correct. Yes, we basically turned our app into a promise all. And you are, Rob, you made my point. Yes, this is exactly what I'm getting at. Like, we have the natural tendency in our imperative thinking to turn things into promise all. So React doesn't let you do this very easily because you need a caching solution, components rerun. It's kind of like a saving grace that the system completely explodes if you try and do this. It's not convenient, but it's kind of like a saving grace. But when you have a reactive system that's actually reactive and can update the stuff and can be fine-grained, you just gravitate towards doing it this way. You know the right solution. You know the right solution is pass the promise through all the components, go through all the types and check if the differences are and push them to the leaves. I was arguing that people probably wouldn't move it into event handlers. Good luck moving them into component properling patterns or whatnot. And the funny thing is, okay, you said yourself, how often are you moving from sync to async? But even think of the process of new development, what people are going to do while they're developing new features. Maybe it was just a user page. And then maybe over time, you added user sections and user and split it out and started things got bigger and started adding maybe nested fetching or just like they started naturally expanding out under their own weight as features come in and increase. Everyone can picture this. You start here. I mean, I don't even know how anyone can make like. I know there's no science to developer experience, but like, this seems very obvious to me. So the whole question is, what if you could write this and have it behave like what we did before with all the uses? Actually behave even better. Pretend the uses are in every single reactive expression. Pretend the awaits are pushed down. Pretend that in between here, if you decide to make a full name, like think about what if somewhere in here you needed to do something like make a full name? You'd have to consume with the use. If you didn't want to consume with the use, you'd have to go like promise.then user.name to full name. Like you'd have to compose the promises if you didn't want to use hi, right? Like I don't know why you'd want to do that in this case, but what if you want both of these to get user full name and you like it was an expensive calculation, not something you want to repeat in multiple places? If you wanted to do it at this point in the tree where you're holding promises, you either have to block here now, or you need to actually like make promise changes on derivation. Like, you know what I mean? Like, how do you deal with it? You're like, okay, well, user.then u.name to uppercase. My examples are dumb, but my point is that if you're not dealing with user, you don't get to just go like that. I mean, you can make more, you can make more async derives, right? But if those derives are blocking, like if the pure presence of a weight causes the behavior, like is the use, how do you do, like, then you shouldn't be awaiting. You should be, like, if the compiler is looking for a weight and you don't want to wait behavior, then you can't use a weight. Then you're probably going to use then. Do you know what I mean? Like, it was like what I was talking about earlier when I was trying to figure out how to write the example in the Excalidraw, where it's like, I don't want to await here. I want to await here. I want to pass the promise through. But what if I actually have to derive something from the promise before the point that I want to await it, and I want to await those in two different locations? Well, then you basically promise chain without using await, right? Well, it works like promise all in a system where the consumption or the blocking or like the trigger of saying like where is my suspense boundary or whatever happens where the await is or where the use is. I like the suspense has to be above that. You know what I mean? Like that's why it's like promise all again. In this phase, I probably would have started with either drilling down user ID or adding it to context. Yeah, I mean, adding to context helps in a sense, but like what I'm getting at here is like it removes the prop drilling, but doesn't completely remove the structural thing. At some point, like you could just make context for little clusters of like 3 or 4 components, but at other points you're just like, look, this is a small tight area and it grows over time. Maybe it was one component, right? Like sorry, where I want to get back to my example here. The truth is, you probably, when this was all the same page, you probably did this. Not even derived, used. What I'm trying to get at here is, if I made this example in Solid 2.0 and I wanted to use the name here, me simply doing something like uh, upper name or whatever, upper name equals create memo. First of all, there's no await here. If I just go user dot name to uppercase, not blocking. This is not blocking. It's blocking where upper name gets used somewhere else down in the DOM. It's literally by design optimal. This is why I was trying to show in this thing. See the difference here? 1 and 2 happen here, solid. 2 and 3 happen here. Right? And by almost enforcing it this way, where there is no separation, but like 1 and 2 can't go together by design. I like you want to separate 1 and 2 as far as you can in the hierarchy, but they don't go together by design. These ones give you you have the option to separate them, but that option takes work. Whereas in the colorless system, 2 and 3 are tied together by design, which means that 1 and 2 can't go together by design, which means that like essentially you go in and you do the most straightforward thing, and that is exactly the optimal solution. To me, that is DX. I know like people like arguing the DX case, but like I mean, would you trade that for split effects for something like effects you wouldn't even use? Hopefully, like yeah, waiting inside the component seems too restrictive to me. So he wasted. Of course, the whole point of this is that components can manage their own data. More realistically, Inner would be responsible for creating its own promises, but you can do it either way. We're not experiencing things. Yeah, waiting inside the component seems too restricted to me. I just think of how people tend to model their data in one place. Well, we try to push them into some means of co-location, and it makes sense to. It isn't something I can make a hard constraint. So composition has to flow. I consider it much less constrictive since you get to choose where the waiting happens, and it's nice explicit. Yeah, but if await always means blocking, do you know what I mean? Like, in a sense, have we overloaded the term await? If we make await mean use, have we actually constricted the language, right? Like, have we actually specialized? Is actually await now a subset of what it was originally instead of a superset? Like, are we actually limiting the language in a way that gives us less capability? Because await always meant blocking in JavaScript, don't get me wrong. But in our case, awaiting, because we can wrap stuff in wrappers, awaiting doesn't mean blocking because we don't hoist it. Awaiting just means it's awaiting a promise. It doesn't mean blocking the render flow. So if we equate await with blocking the component or render flow, then we're basically actually producing something more restrictive than something that's like more expansive. The spice must flow. Yeah, don't get me wrong. There's a couple trade-offs that come with colorless async, mostly around initial load scenarios, which we've talked about before. But generally, and actually, it mostly comes out with interaction from outside the system. That's a better way of putting it, because I mean we've actually talked about it today. There's this physics that the trade-offs are where we started the stream from. This physics. But the thing is, these trade-offs should exist anyway. Do you know what I mean? Like, aspects of it. The more concrete trade-offs is like, if it's colorless, you might not see it. So like creating the affordances might not be as obvious, which is something that like you have to get in the pattern of. But the funny thing is, when you're building UIs, you're already creating affordances. That's literally what your job is, right? You're like, someone's going to be like, oh, I need a loading state here. This emerges from design rather than needing to emerge from technical programming constraints. As I said, I have a very different view of what DX is from I perhaps because it's not about like how easy it is to type or like how many less characters you typed. It's about aligning correctness or like not even correctness, even optimal model with what you write. I want when you write some code, I want it to be the most performant code. I don't want that to be a question. I don't want it to be like, oh, well, you can do this optimally by doing this. No, it's like literally the only way you can write it is the best way to write it. Like that's developer experience to me. If it meant even typing twice as many characters, that is still developer experience. I mean, okay. Technically speaking, it's not in my graph. You can always box value this where you could pass the promise around. It's not easy because we absorb promises naturally here. This is one of the debates I had when I was working on Solid 2.0. The fact that create memo can just absorb it was like a debate because when it was create async, it was easier to do it the other way because like it is possible to pull the fetch out or like store it in a memo, kind of like do this, like what Svelte is doing here. And then only like absorb it in the create async lower down, but it's not even absorbing it. It felt really pointless because the switch from memo of promise to create async of value had no meaning in Solid because it did not represent actual consumption and it didn't, or the read. So it's like, we just like two-step creation for no particular reason. Of course, as I said, the promises can come from outside the system and you can absorb them into memos in multiple locations or whatever. Like creation doesn't have to happen inside the memo per se, but the benefit of it happening in this kind of directed flow is like, this is why I like modeling async as state graph because there's a tie between this and from props user ID. It goes all the way through the async. It's why React has changed their model for async and why everyone's kind of flip like don't use effect to fetch because that breaks the chain. So technically, yes, if you want to do extra stuff for no reason, yes. I don't know if I made this clear enough, but like the difference between 1 and 2 and 3 separate versus 1 and 2 and 1 and then 2 and 3 separate. But it has profound impact when your temptation is to actually always write it this way anyways. Even in those co-located cases, sure, it won't make as big of an impact. You can be like, this is not that big of a deal. Like, let's be fair. You're blocking effects here. So technically speaking, you don't necessarily have to block propagation through graph. What's really cool with Solid's approach was that I think I've shown this demo, the Stack Blitz demo, several times now. But let's pull it up here again. The nested component example, right? Nested fetching example. And Rich remade this with Svelte to actually prove the point here. Naturally, when Svelte first 5 came out, they couldn't do this easily because they had to like decouple a couple things because of the way they did it. But like this was just automatic install. The idea is each component, like A renders B, B renders C, and each one fetches its own thing in 3 seconds. So in theory, if this was the consumption point, like if this was the await in these examples, like if we were blocking here, then this whole thing would take 9 seconds to load, not 1, 2, 3, right? So like the whole thing's under a single loading boundary. So like it doesn't matter. We don't have the ripple down effect, and because of fetch in parallel, it doesn't really matter. It's loading it's coming in as slow as the slowest one in this case in terms of the boundary. But my point is that like this is just a natural outflowing of the thing. It doesn't require any special compiler consideration, any kind of thing. It's literally just how the system works because this isn't the consumption point. The consumption point is inside here. So we can render B without being blocked by A. And I said there are other ways around solving this problem because the whole detection consumption only really matters probably on boundary locations, but it does make, as I've shown in that previous demos, boundaries really, really permissive. We can just move them around or whatever, because like this aspect is you don't have to worry about where consumption happens. You don't need to inject those uses. It's just it's just a result of the system. So making a point, you should assume everything can be async and add additional loaders around everything. See, and the thing is, this is the result why people are skeptical about the DX on this, right? Because they're like, oh, well, now I have, everything. The thing is, you get this naturally falls out of responsibility. Would your component give affordances to show async? If it does, like if you make a button and it should have a spinner as part of its design, then you're responsible for showing those affordances. You would have been doing that anyways. If it doesn't, then that's not on you. Yeah. More like try the app loader. That's right. Yeah, component library. If I go look at Cobalt or look at one of these component libraries, like pull it up, are they providing loading affordances in their components? If they are, then this affects them. If they're not, then this doesn't affect them. Someone else should be blocking that. Like if it stops being it's not about handling async, it's about UI affordances. Think about it. If something's loading, you can't click on it. It's not necessarily the responsibility of the button in that case. It's the responsibility of whoever is loading the data, or like in terms of like grouping this. The thing is, once you get past that initial state, everything flows naturally anyways. That's not really a problem. As long as you don't do stuff, like read after writes in your events, like that kind of stuff. Like as long as you structure stuff that follows the rules that we've been putting into the warnings, then you're fine. I think people worry about this way too much because they want to poke a hole in it. Because you're right, if you try, you can find examples that can poke a hole, definitely. But the real question is, you shouldn't be responsible for anything more than you already were responsible for. How do I know that component supports async in such a way with color? Okay. You never used color in Solid 1.0. You never used color anyways. Did you guys did your components accept promises in Solid 1.0? I'm assuming they didn't. Like I'm thinking that they might have done something like if this isn't provided, like if I don't have a value here, show a fallback. And you would still do that. You're like, if I don't have a value here, show a fallback. But you weren't passing promises around before, so why would that change now? I think I don't think the math has really changed here. I realize this is the thing where everyone gets like really hung up on this because they're like, oh, if anything could be async, then it could be async. Then how do you do it? Now, there are places where async reads could break, like top level of a component. Then I mean, like it becomes kind of awkward because then you're re-rendering the component. There's no thing. But as I said, if you follow some specific rules in terms of how to guard reads, the same as our, like as I said, now we're a little bit stricter on reads and warnings. The rest of the system just falls out of it. Well, I mean, people, because it suggests that it can take an async value. I'm kind of arguing that yeah, I'm kind of arguing that it doesn't, it doesn't matter. Yeah, solid was always this way. Yeah. Yeah. So like, I mean, don't get me wrong. This might be like famous last words kind of thing, and there's going to be like big pie in the face moment. But my suspicion is those pie in the face moments are going to be people trying to break the system rather than trying to actually um, follow the patterns. And I think that the challenge here is that there are some pattern differences. So like, you do have to be a little stricter. And I'm hoping that the warnings and the setup around the arrows can make that happen. Yeah, value or null. Yes. This the one gap, and this is it. On the initial loading, if you read a value in an event that is not used anywhere in the DOM, it is possible that an async error can be thrown. So as in, because if it's read in the DOM, it'll be caught by loading boundary. So if it's above a loading boundary, or like not read in the DOM, there is a small window at the beginning of on the very first initial load of the page that you could read something that throws. And in the past that would be null, but since we were not allowing nullable values, that will throw. This is basically the only gap in here. And the reason this gap is concerning is because it's not, you have to hit it to hit it. Like like you might not realize it until, in theory, someone went to production and they clicked the thing really fast during the initial page load before the rest of the content loaded in. Afterwards, anything about will be caught likely in a transition, but there is this window, this window on initial load where it is possible if something isn't used. To be fair, if you weren't null checking the value in your event already, you would have this exact same problem, right? If it was user and you didn't check if that user was null, you would have, can't access name of undefined. So in a sense, we can't guard you from that. How would you have solved that in the null case? You would have null checked, which null checking everywhere is also not great. It's one of the stinks of representing async as being nullable. This is something that I talk about a bit in the article. The better fix you would have done is disabled the button if the value wasn't present. Note the funny thing about disabling the button is it puts an attribute on a DOM element, which puts it in the DOM, which means it gets captured by the loading boundary. Have you thought about making all signals within the scope ownership of the component be registered with the loading boundary? You're blocking again. That's the svelte problem, right? Or it's the dependency extraction problem. How am I supposed to look at the event handler? What if that event handler gets passed in from a parent? Yes. Yes, it's scalable in flight. Yeah. Which is actually consistent. They interact with what they're seeing. Yeah, sure. We can create an explicit Dep's API for callbacks. If you really wanted to. I don't think that's really foolproof though, because I think where it gets really more interesting for a component author is that the parent not only renders you and might be passing you async data, they're also the one providing the like on-click callback. So you and your local scope can't even see it. So that doesn't solve the problem. This doesn't really solve the problem. They at the parent scope could make that call, but if they at the parent scope are making that call, then they could also, pass a disabled to your button because you expose a ready not ready condition. Your button has a disabled prop. Like if you weren't handling the affordance anyways, you probably, if you were handling it, you probably exposed a way of triggering it. And if you weren't handling it, they're responsible. Like nothing has changed here. TypeScript made null checking common, and it's also null checking is one of the most painful thing to do with signals too, right? Like because the function calls are idempotent, so like it's kind of awkward because every time you call it, like you're like this is definitely a value, and then the next you call it like it's like I don't know that. And it's like no, I just freaking we know it's a value. I think if you click anywhere in the page before it's loaded, you deserve the error. I mean, a little. I think if you build well designed APIs, this stuff will flow out of the language of like the affordances you built into AI UIs. I understand how this stuff can be missed, but we're talking about like the edge of the corner of the corner of the corner. And mechanically speaking, this enforces that you do the right thing. I'm hoping this makes sense or sells. I get the pushback a bit, but like I really think we're onto something here. Like this is I don't know. This is really powerful stuff. We've kind of taken these physics, these rules that are true, and reimagined them through a kind of place where like we've actually pushed a lot of the harsh realities to places where you would expect to deal with them already anyways. And what we've done is kept the inside, kept your graph, kept your experience the way you would hopefully expect this to see it. I it's why I still love this, not this one, sorry. Why I still love this optimistic data example, because the difference between the synchronous app here, where you just show your to-dos, do all the stuff. There's no promises in here. I can't even see any async in here. I just wrote a to-do app that works. And I've managed to put all the actions, all the optimistic updates, all the I thought I fixed this type issue. Is this an old? Yeah, it's probably an older version. It doesn't matter. We pushed all that into the data layer, essentially. Right? That's an option. We don't have to push it all in there. We can break it up, modularize it how we need. But the key part is that the act of building the UI, of describing what you want on the screen, for me that's always been the maybe it's because I have a hard time with like CSS or whatever. Like this is the part that I've always wanted to be able to model easier. You know, I mean, the data modeling is straightforward too. It's very powerful here. But what I'm getting at is we've kind of isolated the async from the UI design. Like if you need an affordance, it's not, you're not asking about async. You're not like, oh, what's the timing of this? You're not going, oh, am I like, is there this race condition? Do I care when I set loading and don't set loading? Do I need to cancel it with an abort signal? That is not what you're doing. What you're doing is you're like, okay, well, this is basically the same app as I had before, but now I need to consider if something is pending, then I should show it like this. If there's an error, maybe I should give a retry button. Okay, or if it's pending, maybe I should show this. Okay. Okay, cool. Like we kind of isolated time from the equation. We haven't isolated the need for establishing affordances for when things are available or not available. We've actually strengthened that. We've given it like you ways to query, like, is it pending, is it not? We've given you ways to look at time as flattened onto your UI plane, so to speak. We've kind of collapsed that dimension in a queryable way. But there's nothing here is like I'm worrying about race conditions. It's literally like, just I have some data, it's either errored or in flight or like pending or whatever, and just show the thing that I want to show. Everything else takes care of itself. Dude, you're on something. In the future, we're gonna wonder how we ever lived without this. Yeah, we'll see. Maybe this is too late. Maybe AI will just do everything, and no one will even care about this kind of stuff. Okay, well, there's a couple mechanical things. I spent longer on this than I expected to, but there was a couple more mechanical things that I actually want to show, but we're actually already at like 5 hours, which is kind of unfortunate. Because I actually wanted to. I mean, I don't have much this week in JavaScript, to be fair. I don't care about Vercel versus Cloudflare. Honestly, most developer news just doesn't interest me even remotely these days. No one's talking about actual stuff and approaches to building things. They're all just saying like AI, blah 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 blah. You stole this from me, blah blah blah. Like, really, just like drama. I can't hear. No, what I want to talk about a bit here is I want to pull up the repo, and I want to show an example here because I think it'll help. Not, it's fine. Solid.js. Because I want to get into some more mechanics here, and I think it will be interesting to do so. These should be fixed now, but I've showed this on stream. But I think this example that was made by Mizulu is actually really relevant. It's called the double. So, like, a lot of these were bugs that I fixed, but there is one of the ones that was actually not a bug, and I was like, this is not obvious, and we should talk about it. Is it this one? Oh yeah, beautiful. All right, let's dig into this one for a second. Or it's broken. Lovely. Okay, that's fine. I can demo this in a different place. Yeah, let's demo this in a different place. What's the best way to demo this? Yeah, okay. Okay, let me take my multiply divide example, because I want I think this is really important to understand about the model, and I want to let's use my divide example. Yeah, let's do this. Okay. I think some people have seen this before. You click, you go, and you can click it multiple times. It only settles once. These are all separate async reads, but they all get entangled, and you get the smooth thing. And the key for why this example is so cool is I literally started an example with no promise here, and it just is a bunch of memos, and then I just decided to make it async, and I essentially I don't have to worry about null checks. Like A is actually an accessor number, so on. N is always going to be held where I want it to in the past, arguably. Here, I'm actually purposely tearing, so like 12 gets ahead of 12 because I use latest N. But let's do this. Let's remove the latest for a second, and I want to show you all something. See, if I do that, it's not going to move, and this is the default behavior. It'll stay on the number until it's consistent. Now, what Mizulu did in their example was they moved the button outside of the loading boundary. And I think this is important to understand because so far this is the same, and I click it like 10 times. But one thing that I'm doing here, if you've noticed, is I'm actually passing a setter function. So I'm incrementing it by n+1, which means it's actually getting the latest value. Incidentally, that's just how we work. If I changed n to actually read things, so it reads the stale value, right? So it's actually does a reactive read. It's not like applying a callback function on its previous value. You'll see if I click it multiple times, it can only go once. So I click it 3 times, but it only goes up once. This makes sense because it sees the same stale value and it can only go once. So if it's on 2, it's only going to see 3, and then it tries to click it again, it's going to see 3, it's going to see 3. This makes sense, right? If this was latest n, then it would be the same as the callback form. But essentially, now if I make this timeout longer, let's say like not random, if I actually make it actual 500 milliseconds for each one, let's make it even longer. Make it 1,000. 1 second. You see, as I'm clicking here, it stays on 2, even though I click it like a bunch of times, right? But and this should make sense to people, right? Okay. We're loading, and then we show all the state consistently. Like obviously, it's a nice affordance to get latest, but the interesting question is, what do you think happens if I click the button while the page is loading? Like a bunch of times. Does anyone want to guess what happens in this example? Should it behave any differently? So here we know but my question is, while it's loading right now and I click it a bunch of times, what do you think is going to happen? Chat, I am going to wait for you guys to respond because I don't want to ruin it. Okay, Robbie says it'll go up faster. Why will it go up faster, Robbie? It will go up, but I know. Yeah. So is it the people who know the answer are the only ones responding? That's fair enough. It's not about replaying events. The page is this is client side hydrated or whatever. Everything will crash. No. Are you guys ready for me to do it? I'll give you a moment longer to guess if you want, but let's do it. All right. Last chance. All right, I'll do it now. It went up to 11. In fact, as I kept on clicking here, I could actually hold off the loading going away. Got to 30. Why is it like this? It updates right away. It doesn't hold. See here, we're holding, and then it updates. Isn't that weird? There's actually a really good explanation for this, but because AI saves consistent. Yeah, there's nothing to contradict it. The backend will handle it. No, it's because it. So, so secret little goblins counts the number of clicks during hydration. No, this isn't hydration. This is completely client side. The app is fully hydrated by the time, like the like there's no hydration. The reason that this happens is because there's nothing to contradict it. We only need to show, we only need to hold the count because there's something to contradict it. Because we need to be able to show that 10 divided by 2 equals 5. N itself is not async. It gets held up because you can't update the number while showing A, otherwise you'll get tearing. But when it's loading, like there's nothing to tear essentially, so it can just process it immediately, right? There's no dot 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 on this either when I'm clicking on it. It's not pending while I'm clicking on it. Now it's pending, but there's no pending while I'm clicking on it right now. And it defers loading because it does load it a number of times. It cancels the previous ones. You know, we have built-in promise cancellation, essentially. But that's basically the gist of it. Now, obviously, it's weird that I click this 5 times and it only goes up once, and here I click it like 10 times and it goes up faster. So arguably, the behavior you want isn't n plus 1. It's latest n, or you know, simply this. As soon as I change it back to this, then you get the 5 right away. And when I click here, you know, you get the 6 right away. Like, so now it's consistent. And when I click it a bunch of times, I still get the number of clicks aren't lost. And if I go back to this being latest n, so you want to show the updates right away, there's no inconsistency between this and this, because that's the affordance you want to do. That feels much smoother, obviously. But I did actually have to make some considerations here, right? Because the default, but like what I'm getting at is I made this decision based on like a local decision. I decided that my affordance is like, I could, with the button increasing faster, I could choose not to show the is pending. Like my affordance could be just the fact that this updates. That could be my decision. But what I'm getting at here is that like it is important to understand that loading boundary is a boundary that guards. If the async read from ABC here doesn't escape the loading boundary on initial load, which means that n is not pending, or like n can update right away. Yeah, this makes sense from a system where it's verging on being counterintuitive. Yeah, and to be fair, this is how React works too. I think this probably has Svelte works too, I imagine too. I'm not sure. Yeah, I imagine. I mean, I've already been doing demos that were closer, like the to do MVC type stuff where you're managing a list. This demo is not going to. I I don't think real world case is going to actually help explain this demo anymore. This like this is another one of those ones where what are you doing jamming the button while the page is loading? You know what I mean? It's it, I this is the this is the funniest. I have to test and make small examples to show edge cases because in the real world you just don't tend to hit, like you will like on occasion hit these edge cases, which is why we have to account for them. But like we're not setting ourselves up to try and hit the edge cases. You know what I mean? I have to account for them so that like when your app scales, when you get to a point where you hit these things that they're handled properly. And this is why I'm very thankful to the beta testers, because the type of people who hang around the Solid Discord are exactly the type of people who want to break everything and poke holes in everything. They want to create crazy demos so that really show off like the capabilities, and they also want to show their cleverness. So like I get great examples of people trying to break stuff. So yeah, I mean, what what's a real example? I just said something like to do MVC with affordances is very similar to like a Trello board conceptually, which could be a real use case. A lot of times, the funny thing is these little cases that we're focusing so hard on in making these demos are like so on the edge of thing. The real win is just being able to write the code like normal and not have to worry about these edge cases. Like let me see. Give me a second here. I'm gonna open Discord in my other window for a second and see if I can pull out some examples that the community have been making using Solid 2.0. I think Gabriel's still here. I think we just saying everything stays the same is mind blowing. Yeah, the two MVC examples really great. What I wanted to actually grab was Gabrielle had an example uh, that was like a chat app that was built on on this, and I think it's in a working state. I need to see if I can find it. Is it the Sync Engine chat? Yeah, let me see. Yeah, you guys can see it. Yeah, sorry. It's all good. Hopefully this demo is working. I might have grabbed a bugged version of it. I love this example. What was this example? Format temporal zone. So what are we doing here? Chat app, create projection, which is an async iterator, querying messages. Push store, create optimistic store. I don't have enough context probably to to look at the implementation completely in here. Chat pane, what's in here? Badge, scroll behavior, message list, message bubble. I just love that. Like most of these look like they're just dumb UI components. Do you know what I mean? Like they're just doing stuff like synchronous, nothing too fancy. Props children. There's a wrapper. Yeah, okay. So almost all the logic, this is some special scroll behavior. Almost all the special logic here is a for loop, which is keyed false, so it's by index. I wonder if repeat would be good there. It doesn't really matter. This might not even be the latest version. All the logic is basically the chat app component, right? So it's basically we create a projection, which is an async iterator, and then it just gets the messages and yields off. And then the optimistic store mechanism messages. See how does that, where are we setting our optimistic messages? We have an action that sends the messages, sets them optimistically, pushes them on an array, and then it waits on the API to send the messages, and then it looks for the message ID. Yeah, I get it. So basically, when it gets an ACK from the server, like it gets the message back, it knows that it's done its action. I hear that some things like Convex automatically like hold your request till they know you've received it on the client, but this is cool. So this is basically a fully streaming chat example that's just using async iterator protocol. Like it's fun. Like there's no imports here, right? Like this is literally like just built purely using our primitives um, to basically have two chat apps. They work both ways. So I go hello, yeah, and they what's up? Yeah, I mean, I did a bunch of fixes since the last time, so now we can actually have the streaming async iterators work, and they have multiple modes, which is really cool. For hydration, you can either choose to do the default where it just streams from the server all the way through the hydration, or you can do hybrid where it streams the first promise from the server and then picks it up from the client. I mean, I actually got a demo I could probably show off here to that effect. Why is this still here? The weird part is, did I close one of my windows? I feel like I accidentally closed. Like where did, yeah. Oh, it's because it's full screen. Haha, it's fine. Um, uh, I'll just copy paste this into chat in case people want to check it out. I don't know how presentable it is. I know we've been working in bug fixing throughout this whole demo, so but what I wanted to actually look at was uh quickly look at a couple of like silly little demos, incremental SSR incremental iterators. I made this example on stream last time and it didn't work. Remember? Um, where it pushes into a list. And this is actually kind of a cool API just on the side, because what I did was the projection is a stream, right? That pushes values on. So it's actually incrementally. It's not sending the whole list over the wire each time. It's literally just adding an item to the end from the server um, once a second. And then the client just appends the item on the end. So we're not actually sending the full list. We're actually doing incremental pushes from the server during initial SSR. There's no additional requests or anything. And what I did to actually prove this fact is I put is server. See, StackBlitz has this funny, it's not, I guess not funny, but StackBlitz will show you server and client console logs in the console. That's how they forward them through. So I actually had to like prove that C chunk true. It's actually running on the server, these chunks coming in. And what we're actually doing, if I look at the, maybe I can put this in a different tab. Sometimes I have problems with StackBlitz from a security standpoint. Oh, it looks like my computer is low on battery, even though it's charging. It's charging slowly. Cursor is killing it. Okay, let's kill Cursor for a second. Sorry. Maybe that'll help it recover. I was trying to build a signals library from scratch using Solid's tests. I wanted to actually see if I could do the vNext thing against myself. We can worry about that on a different stream. So Hopefully our computer could start charting. I'm only at 7% left, so that's kind of bad. Let's quit. Why is Chrome being weird? Oh, there it is. Okay. Okay. So it's still telling me that Cursor's using a lot of it. I think Cursor's done now. Is it still that sitting there in the background? Okay. Anyways, let's bring this back because okay. So but one thing that we can do that's kind of cool here is instead of doing this, we can change the SSR source to be client. Let's hope this works in this version. But if I change it to be client, now same demo, and what you're going to see is false. Now it's the client side making the connection. There is one difference though. There's no loading boundary because it never suspended. It literally just picked it up on the client and made the request on the client. So, I mean, this is good for like tapping into async local storage, or sort of like async storage, like local storage type stuff. But it's probably not like typical for this use case. But the real fun one is hybrid, because with hybrid, if this works, is it should be true for the first one and then it should be false. Okay, and I have a hydration error in this example. Hopefully I have to fix that now, but see how it's a true and then false, and then picks up the stream. So it actually serializes the first value from the server and then continues the subscription from the client. And this is all just a matter of choosing what your source is for your data fetching. And make font bigger. The font's actually already kind of blown up. What are we at here? 125%. Usually I have a hard time reading my screen if I get any bigger than this because the code doesn't fit. Anyway, just kind of showing some of the stuff that we've been doing with the async boundary stuff. Okay, so there is. How was it skipping? That was a fun part because you have to understand it's doing incremental updates. So I actually had to, eat, because if it was yielding a value, that would be easy. But if you look at it, it's not actually yielding a value, it's actually mutating it. So I actually have to eat the proxy has to actually eat the updates on the first iteration. So it takes the server serialized state and then replays the first one, but then like basically when you push or do any mutation, it just basically eats it. It gives you an object that is mutable and you can read and is self-referencing and all that kind of stuff, but it doesn't actually apply it to the underlying draft. It doesn't. I mean, there's not much you can do with the async iterators. There's not much in their protocol. You're going to error out and you're going to get an error boundary and you're going to do what you need to do. Yes, we can't skip it. Yeah. So technically, yeah. So if there's a log next to push, you'd still see the first value repeat. Yes, exactly. Yeah, we can't stop the first thing from happening. But this was a good example because it was a push. If it was a yield, this would be really easy, right? You just skip the results. But because it's mutable, yes, it does run on the client. But it's kind of like the way create async runs on the client. Or not create async, but like for promises, we also run on the client and we kind of like dummy out the promise so that we don't refetch because we have to collect the dependencies. So it's a similar trick basically that during hydration, we sort of we have to run the code, but then we kind of patch it so it doesn't do the thing we don't want it to do. In the case of async iterators, I can't promise that it's not going to run the promise like normal data fetching, but I think, but generally that's the kind of tact I've taken here. That's so funny. It's still showing cursor using significant energy, even though cursor is not open. Anyway, that's fine. Okay, what I wanted to talk about next related to this stuff. Yeah, so I think the main one there is kind of what I was showing before, which was like this idea that if you have a graph, right, and you have let's make the screen write something on it. So here's your like signal, right? And then let's make this red. And then we have something like async derived from it. How does this show this? Yeah. White. And then let's put blue, which will be our effect. Like if you have this kind of chain, where the loading boundary happens, I'm trying to think of the best way to show this, but essentially we don't let me stop. Delete. We don't consider things having. I'm gonna draw something up here or use a word. I'm gonna write transition, okay? And transition is gonna be brown, I guess. It's gonna be like do you have any more shapes of a diamond? Yeah, I don't know if bring to front. I don't know if my diagrams here are going to be very useful here, but conceptually, the way this flows down is when we hit our async update or async signal, at that point, until we hit something async, there no transition exists. We just kind of collect the nodes in a global queue. And then when we hit something async, we go, okay, create a transition. Dot 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 this. Let's make this a little bit get you. We're like create a transition, but the transition doesn't do anything concrete. And then when we finally hit our render effect and it holds, at that point, it goes, it starts bubbling up its owner graph. So this is a dependency graph here, okay? So dependency graph is white, let's say. Then it looks up a different graph. It looks up its owner. So let's go here. Let's use blue. So it looks up for its owner. And in our case here, like these might be the same owner, they might be a different owner. We're gonna make this transparent. These can be where these owners don't matter, but it walks up its ownership graph and it goes, hey, I'm async. And if nothing gets in its way, it'll get to the transition and the transition will go like, okay, what, like, why did you error? You erred because of async. We actually communicate the node along here. So then this async node becomes registered with the transition and we know how to wait for it. However, if on the way up, it hits a wall, and by wall I mean like loading boundary, that communication never gets up here, and this loading boundary goes, ha 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 ha, I will hold on to this async. Yeah, so it's good. Loading, you be there. You, yeah, sorry. The green arrow is gonna be, so this then goes to here. Indirect, yeah, this, my arrow drawing is terrible. Because like essentially if it hits the wall here, instead this goes to here and it never makes it to here. And that's like mechanically the core of the transition mechanism. And the key part is loading only happens initially, generally. I actually added a new prop that if you want to trigger loading to start again from above, you can. The biggest problem with suspense is if you have some random async down below, it'll just keep on unmounting on you. But one thing that occurred to me is that sometimes you actually might want to isolate the change. Yeah, that's actually what I wanted to do. Do we have the divide example anymore? I think I undid all the changes in it. Let me go back to it. Yeah, so let's undo all the changes in here. Whatever. Save. Let's go back. In the divide example we were doing earlier, where we were you know, locking it up. So let me see if I can do this. And now it should lock up. Yeah, this older demo doesn't have HMR. And then, oh, but then I'd have to update it to the latest solid, wouldn't I? This is like experimental 16. Let's fork it. Just yeah, let's fork. And then let's move to beta 4. Beta 4. Beta 4. Beta 4. It's funny because now that I have Beat plugin, this one seems like a little bit outdated. But okay, let's go here. Let's make this N. Okay, good. If we wanted to, we could say on N. And no, I hadn't tried this yet, so I was hopeful that this would do what I wanted, but maybe this is not working yet. Okay, lovely, not working yet. Okay, that's fine. The idea is that if you said on N, it means that whenever N changes, we reset the loading boundary so it can go loading again. What's cool about this is you can control it from above, so you can make the decision, like let's say you want to kind of key it by page or something, and that way you can isolate these changes that happen above and not wait on the stuff below, so you can keep the stuff faster that way. But the key is the important part would be that random async happening below, unless it was triggered by this change of N, wouldn't cause the loading to reset. Basically, other async, it doesn't matter. This is you controlling it from above. Of course, demo's not working, but what else is new? I'll look into that. But yeah. I'm guessing a lot of the changes to signals must make them very open to sync engine integration. Yes. Like I saw sync engines and I'm like, this is fine grained over the network. Solid is fine grained on the thing. This is the perfect pairing. If you care about sync engines, you should be using Solid, like no doubt. So I wanted to. A lot of this thinking is to make that seamless, essentially. Errors in green. Yeah, I don't know, whatever. It's fine. I need to work on my way of explaining the model better, but essentially boundaries have the ability to stand in between. Transitions are global, boundaries can stand in the way. Boundaries are resettable, but generally they only run once unless as the default behavior, which is where you kind of want to be. Because you don't want things jumping out on you out of nowhere. And optimistic updates are just another layer on top of the transition. But I don't think I'll get into a good graph of drawing them today. I thought maybe I would like explain how optimistic updates, optimistic lanes layer on. But if I can't visually show this properly, I'm pretty hopeless to visually show that. Let's move on. Okay. I think it's just time to wrap up with a little bit of this week in JavaScript. Chat's getting quiet. I can tell it's the end of the day for all you all. Give me a second as I split modes. All right. I have so much open stuff right here right now. Just closing all the crap. All the crap. All right, so what do we got? I'm actually like seeing if I actually have anything. I feel like I literally released the article and okay, yeah. Is that? And sorry, 2 seconds, chat. I'm just getting everything opened up. Okay. All right, cool. Let's go back to here. Let's go back to here. Beautiful. And then let's go back to here. Yeah, okay. Yeah, I don't have much this week, but that's good. All right. Let's share my screen now. Talk about this week in JavaScript, which honestly isn't going to be that this week in JavaScript oriented, I don't think. In general, because I mean, I highlighted that story with multi, but I don't even know if I want to talk about it that much. Okay, so yeah, I'm gonna start with solid stuff. It's easier. Saw this, thought it was really cool. People always ask about solid on native. The native script guys are very on the, like they're very quick to kind of jump on these things and make sure that they happen. Tanstack router solid with Vite, which is a very cool story for us, obviously, because Tanstack router is very cool given its TypeScript routing. And here you go. This probably could be a really awesome way to develop on mobile using Solid. Then there's my HackMD. What's this one here? Managed to get Vike, SolidJS, and Spacetime DB working. The instant sync is so fun. Feels like Convex. Yeah, I like Convex a lot. I saw their sorry, this doesn't go here. I saw a demo of it ages ago, and I've always been really impressed with it. It's the challenge has been people like as much as like companies have a certain reality they have to deal with. I think Jamie actually had a tweet that I saw. Yeah, because it's a pity the convex interchange still focused in React, blah, blah, blah. My favorite is Solid. I'd argue it's better designed engineer than anything I've seen, but alas, responsibility to focus on support our customers use. I'd love to be able to invest more attention in other cool frameworks like Vue, Svelte, or Solid. So, yeah, big fan of Convex, big fan of Jamie. I would love to see better Solid integration, but we got to prioritize. I think with 2.0 coming out and the push there, this thing will naturally kind of come out of it. But big shout out to Jamie. And Convex, just as an aside. Sorry, I know that had nothing to do with anything. I just what was I looking at? Yeah. The key point is, you saw in the chat app, we're getting to a point where build your own sync engine might be a thing, and it could even start from like not even a sync engine. The kind of optimistic UI that we're building in Solid, irregardless of the transport layer, essentially doesn't literally matter how the data gets thing, can give the sync engine feel without even having a sync engine. So like yeah, I mean, we're definitely on our way there. Yeah, okay, so that's it. Other than that other story, let me go here. What do we got? Yeah, yeah, a lot of part of advocating for Solid is having to defend React first. A lot of the loudest anti-React takes fixate on ergonomics or vibes, not the actual architectural issues. You can't explain Solid's advantages until you clear that fog. This was a precursor to this article. I knew I was writing this article when I wrote that tweet. I was just like, it became really obvious to me. I was like, I'm gonna have to write a post where I basically point out why React was right and defend it. At the same time, show where the shortcomings still are, but be very clear that, you know, the things that people like to blame React for aren't the right things. It's tiring after a while when people are arguing over stuff like syntax or like how many characters you have to type or whatever. It's just like, there was an interesting, actually, I saw it on Reddit where someone showed that like the least tokens used framework was Marco, and then like Svelte was like third. And then I looked at the list for a second. I was like, this is like syntax compactness. It's not actually probably saying how easy it is or hard it is to actually create the examples. It looks like someone just took like component party JS or whatever, where you have all the examples and then just counted the number of characters of it. It doesn't actually suggest if AI has a harder time or it requires more thinking or whatever. It's basically like which framework has the least syntax. And as everyone knows, Marco is the most compact JS framework, right? You type the least in that one compared to any other framework, even Svelte. So like, of course it won. So yeah, it's interesting. We don't know what metrics really hold up, but I definitely feel like we don't have the right measurements yet. Let's talk about my actual AI article, the one that was actually written by AI, for a moment here, because I don't think I've talked about it too much. It was after my last stream. I basically asked AI why Solid was a good choice. For all those guys earlier who were like, "Oh, what about Remix 3?" This is my response to you. I guess I could have brought this up earlier, but this is what AI told me. You guys can decide if it's relevant or not, but software is entering a new epoch. The era of writing code is giving way to the era of systematic orchestration. As AI agents pour unbounded amounts of imperative logic into our repositories, the limiting factor is no longer human output, it is complexity absorption. In a world where machines can generate infinite working code, the frameworks you choose become only your defense against temporal drift, race conditions, and slow gravitational pull towards technological entropic collapse. The question is no longer how do we write code, it's how do we ensure that code, human or AI, remains correct over time. Solid 2 answered this question with a single principle. Determinism must be structural, not stylistic. I mean, it's a good summary of what I was covering on the stream in terms of the shape of the APIs. The ending of the loading Boolean error. This is kind of like direct response to like the remix thinking. As I said, to be fair, I didn't write this. AI wrote this. This is a completely AI generated. Most frameworks still treat async as an afterthought. A promise resolves somewhere, a Boolean flips somewhere, and the UI is expected to stay in sync. This is the root cause of modern UI instability, a temporal desynchronization zone where data and interface drift apart. This model was fragile when humans wrote all the code. It is catastrophic when AI writes most of it. Solid 2 replaces its entire class of problems with a new primitive, the temporal tuple. It's a funny name. What all they mean is that we have we have latest and value, or we have optimistic and value. Like we basically view all state as now and the future. They chose to call it a tuple. It's not a literal tuple. It's just the idea that you can declaratively show something. Let's see what their explanation. Every reactive value carries both the now and the future. Async is no longer a side effect; it's part of the value's identity. This eliminates the need for ad hoc loading flags, effect cleanup heuristics, and the endless patchwork of fixes that accumulate around async code. The runtime owns the timeline, so the UI cannot follow to sync with reality. Determinism by construction, the gap between actions resolutions where bugs live. Traditional frameworks ask developers or AI agents to manually bridge that gap with effects, guards, and cleanup logic. This is not engineering, it's gambling. Solid 2 removes this gap entirely. By elevating the future as a first-class part of the signal, the runtime constructs a timeline projection architecture. The UI becomes a pure projection of the value's temporal state, not a reaction to its events. This makes the entire categories of bugs structurally impossible. Stale closures, race conditions between overlapping requests, flickering due to mismatched loading states, UI tearing during async transitions. Where other frameworks rely on discipline, Solid relies on invariance. A runtime that can absorb AI generation code. AI does not write elegant code, it writes maximally literal code. In virtual DOM systems, this leads to over-rendering, hook chains with hidden dependencies, effects that accidentally rerun, states that drift because the framework cannot see the graph. Humans eventually lose the ability to reason about the system. Solid's fine-grained reactivity turns this dynamic on its head. Even if the code is sloppy, repetitive, or overly imperative, the runtime constraints put into transparent, observable graph. Computations become explicit, dependencies become explicit, updates become surgical. In other words, even bad code becomes predictable code. This is only sustainable architecture for future where AI is the primary contributor. 4. Stability as strategic assets. Frameworks often chase features, abstraction, or syntactic novelties. Solid 2 takes the opposite path. It invests in permanent primitives. These primitives, signals, timeline, boundaries, those aren't our actual primitives, but good try AI. I guess boundaries are and signals are. I don't know what timelines are. I guess they're talking about like the pending stuff. Form a stable contract between your logic and screen. They are not patterns, they're not conventions, they are mathematical guarantees about how state flows through time. This stability is not conservative, it's forward-looking. As codebases grow beyond human comprehension, stability only becomes the only way to maintain velocity without collapse. Solid 2.0 is not designed to help you write code faster. It's designed to ensure the code you write or the code your agent generates remains correct by default. Yep. The future belongs to deterministic systems. The next decade of front-end architecture will not be defined by JSX versus templates or by compilers versus runtimes. It will be defined by whether the system can guarantee correctness under exponential code growth. Frameworks that rely on human discipline will fail. Frameworks that rely on runtime invariance will endure. 2.0 is the first framework built on this reality. It's not a UI library. It's a temporal contract, a guarantee that your interface will always reflect the true state of your system, no matter how much code is generated above it. I hope so. AI seems pretty positive. It tends to be. How's your overall feeling so far? I think there's a couple places where I get kind of discouraged at times where I'm just like, oh man, I can see why that wasn't intuitive. But then when I go back at it and I go, oh yeah, but it is actually the reality. My biggest concern is making sure that the education is. I actually don't. I think the API shape and stuff is generally good. Like I think in a sense it rolled out. Like as I said, it's not something invented. It kind of like was discovered. It's kind of like following the physics. So like, while there's small pieces, like adding on to loading or things where we can like do these kind of like slight adaptations that can fit some patterns generally. I generally, for the most part, I think we've actually gotten to a really good place, really nice design. Like stuff seems consistent. Like over and over again, I hit like these issues and stuff, and I'm like, oh, that's why we have split effects. Like literally, just like I'm like, oh, this would have been a problem, except the place where it becomes awkward is like legacy APIs and stuff like actual like tracked effect. Like I had to fix a whole bunch of do a whole bunch of special casing just so that we could keep like on mount or on settle as it's called now, or keep like effects not being split. Like stuff like that is the biggest source of my concern, because as I think it's important to like still continue to support people in certain ways, but like those things are doing are really terrible. And it's hard because they're like people like I want to be like this, and you're like, no, you don't. Like everything, like, and it's not like something like, oh, just because of this one reason. It seems like everything flows out of the system that way. You start doing more work, and you're like, oh yeah, split effect saved us again. Save, like, and it's almost like a hammered, repetitive message as the design progresses that just supports the thing. Now, obviously, sometimes that's self fulfilling because like you set the constraints in the first place, which means you come to that inevitable end. So I recognize that as a thing, but it feels incredibly consistent, and reasonable, from where I'm sitting at least. Most of the bugs are there's a lot of bugs, which makes it hard to kind of see the full picture. But then some of the other stuff, behaviors are just weird behaviors, like where you know, like people are doing stuff that is unexpected and really should be forbidden. A lot like there's a lot of the bugs I looked at them and I was like, we should just throw an error there, which is odd, but it's kind of like my picture of the behavior of the system has never been clearer. Okay, I guess that's the best way to put it. Like a lot of the ambiguities are gone. What else we got here? I recently attacked. Oh, Sublime. Uh, okay, let's go into the bookmarks. The last little bit. There's not much to say here. Theo actually covered in his video, and I thought he did a really, really good job. Because like anyone who knows Sunil knows how awesome of a guy he is. But basically, long story short, Vercel had kind of like a bash thing layer that they set up on top of their infrastructure, so that AI agents could use bash in a safe way without like getting to the underlying infrastructure. And then Cloudflare or Sunil saw it and was like, hey, this is actually really useful. We should do something similar. But obviously they don't work on Node. They work on worker D or whatever their underlying thing on their workers. So they had to, a straight point won't work. The challenge here was that just bash was, is this article still here? The gist of it is just it's basically not stable. It's like literally experimental. Like it's not in a place where someone should like copy and fork it, so to speak. But it's obviously the need is there, and Sunil was just testing stuff, but he released it through a public Cloudflare official repo, and they basically he removed all the stuff that wasn't necessary for their environment, and because of the whole Vercel Cloudflare thing going on, the whole thing kind of got really blown up. Like, is this Cloudflare trying to steal Vercel stuff and remove the security and all this stuff? And everybody chimes in. I think Malte and Sunil talked and then everything cleared up. It's just funny, like whenever there's these dramas, things get like way blown out of perspective. Sunil's like, oh, Cloudflare's mission is to fork the entire development ecosystem to destroy open source. VNext was an excuse to swindle developers into. Does anyone take this guy seriously anymore? It's fine, whatever. It's kind of like when I read Donald Trump. I just can't do it anymore. I'm sorry. Let's just continue. The gist of it is that these guys made up, and it was just a misunderstanding. The thing is, it's always like the overreaction things where people end up saying the thing that they like should regret. It's usually not the original thing. It's like the way everything blows up. Like I remember when the whole remix docs scandal stuff happened with us, and like the guy from one of those like venture capitalist companies, that scooped up all the open source companies, was like trying to like flag like Matt Billman and be like, oh, blah blah, and it has nothing to do with Netlify at the time or anything. So it was just like people trying to like stir up crap when they have no business to, because of like getting on the drama. it's unfortunate, this scenario, and that's all I really have to say about it. Um, I think I'll leave on this last AI note because I think I saw this from Dev today and I thought this was funny. So this is going to be injected into every coding agent system prompt, huh? So much for AI is good at React because training data sets. I mean, ensure page listing for React code, prefer modern patterns include use of effect event, start transition, and use deferred value when appropriate if used by the team. Do not add use memo, use callback by default unless already used. Follow the React compiler guidance. Sorry if I didn't like this. Obviously, they will always like being the newest of every framework, but AI still works better with React than new frameworks like Vue. React is more native to JavaScript. I don't even know if I want to read these responses. I feel like I might like just insult people that I just forget it. Let me just focus on what I actually wanted to. The thing is, the AI React is still evolving, and these patterns, including the compiler, including all this stuff, means that React code is changing. The To the point that I don't think this change is hard to absorb. I think AIs have no problem absorbing this sort of change. So like I think just the whole I think this whole AI is good to React training set data thing is complete garbage. I've been saying it for a while, and I if basically if React can absorb that, or if the AI can absorb this easily, then it could absorb Solid or something else just as easily. And people pushing this thinking are just, yeah. I mean, I don't even know what to call them. I don't. It depends on what their motivations are, right? You know, it's a spectrum between swindler and ignorant. So I think I think this I actually I think Ben Davis just did a video about this recently, talking about like Svelte and like how AI is no issue. And I've found the exact same thing with Solid. You know, like there's this is like this is not the argument to make. And I love seeing it crystallize like this one. Like basically React's introducing multiple new primitives that replace other primitives not to use, and also following different code writing standards thanks to the strictness of the React compiler. Like these are all good things to do. It just suggests that React now is not the same as React was 5 years ago, or when like these models were trained. You know, generally speaking. So like there's probably more React code using these proper values than there are some other frameworks codes, but I think the numbers are a lot closer between this stuff and like say picking up Svelte or some other framework. Definitely Vue. I mean, when did Vue switch the composition API? 2020. Yeah, so that fits in. Like, you know what I mean? Like, this is much rarer of a breed. So obviously, if React keeps on winning, React keeps on propagating. But like at this point, it's your own self-fulfilling prophecy. Don't think it's anything else. Recently, AI wrote me a React class component. Well, there you go. Still works. Current LMs are quite good at writing code in total law language with minimal examples. I don't think this is a real thing anymore. No, it isn't. It's funny that we have to call this out though, because I mean, there's people who think this, right? Dev actually humor him? No, good. Um, One thing is, then yeah, the one constant here is change. I don't know how often we have to like debate this with people. Every area doesn't know how to use your deferred value. I agree. Yeah, someone from the Svelte community. No, the reality is this is just not a thing anymore. AI is generally good. All right. Yeah. I'm done too. I gotta go too. It is almost 4 o'clock. I've streamed for quite a long time. Only went a little longer because I started late, but um, I'm actually gonna look and see if anyone else is streaming, see if we want to raid anyone. But to be fair, except for last time where strangely Theo was started streaming right at the end of our stream. Usually there isn't much for the Friday night crew. Yeah, it's all good. Um, you guys all have a great weekend and hope you learned something from the stream. It's gonna be a couple weeks. Oh yeah, there's one more little bit of news. Gonna be doing a Solid Start stream coming up in a couple weeks. Solid Start 2.0 is close to release. It's gonna come out before Solid 2.0, and it's gonna be update for Solid 1. Attila has like a whole thing he posted, but I probably missed. I forget if we were gonna publicly announce something. Let me see here. Actually, you know what? The discussion's public. Let me just throw this up as like one last little thing before I go. Let me throw here. Roadmap, start V2 and ecosystem. Hey folks, long time no talk. Our last announcement was done at the beginning of DaVinci work. We have successfully completed, and I'm happy to let you know that SolidStart version 2 is used in production already in real world apps like Open Code Console. Yeah, nice. As per the last announcement, our plan to maintain Start and Solid in version lockstep. It seems possible the works in Nitro V3, Solid V2, and Start V2 converging to a similar release date. We are now deciding against this plan in order to provide a better developer experience and migration plan for existing Start version 1 and V1, Solid V1 apps. Yeah, exactly. Like you could tell that we were all converging around the same time. For us, the ideal support Solid V2 would also need breaking changes in router and meta packages. However, since the team has managed to keep the DaVinci effort with minimal breaking changes, we believe it's worth the effort to create a stable release in the new architecture in order to lay down incremental migration steps toward the future Solid. Upgrading from Start V1 to V2 requires a small change just to vconfig ts config json, and optionally create middleware signature. Although the internals are much different and improved, there's no change impacting your server functions, actions, or component code. I recommend you to give a try and follow these migration things. Update timeline. Remaining blocks can start alpha, new directive plugin, built-in server-only environment variable support, beta once these emerge, release beta 0, collect feedback, Solid recommended server runtime from Nitro to V3, planned blah, blah, blah. Release candidate. By the time we're confident enough, the API will ship 2.0 RC, effectively deprecating Start V1 and create Solid CLI will official documentation. Solid V2. As the ecosystem adapts to the new APIs and updates in Solid Router and Solid Meta, we will start working to support V2. The likely is not certain supporting Solid V2 means V3 for Start. Yeah, though likely, it probably will be V3. Start V2 will not drop support for V1. That's the idea. If there's a chance to support an incremental migration from V1 to V2 within Start V2, we'll try that. But at this point, we're not trying to make any promises. Fair enough. And I think it's good that you didn't. We are also working on developing plugin-based system ecosystem first package long-awaited image component. Awesome. That's all we're open to seeing. Blah 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 migration. Yeah. So gist of it, very exciting. I'm not logged in, so I can't do anything here. But we Solid Start V2 is probably going to be coming out in the next month or so, I think, somewhere along that lines. We're going to talk about it. We're going to do a stream on it in 2 weeks, and then we'll see how the beta continues going. But then the support for like we still have some time on Solid 2 beta, at least a month. So we'll Solid Start support will come a little bit later after that. Essentially, it might be a quick V2 to V3, but I think it's important that we have the updated basis, and Attila as well, that for Solid Start, so people on Solid version 1 can continue to like get updates and use the latest technology where it is today, and not be stuck in like where we've been in the past with Vinci and whatnot. So bit of news. I just occurred to me, I wanted to get this out early now because by the time we have the stream in a couple weeks, this stuff will be well underway. All right. Anyways. You all have a great one. All right. Oh yeah. Actually, you know what? Sure. I don't know what he's doing, but let's raid CM Griffing. Why not? It's been a while. Kind of on my channel. Griffing. I think he's working on something in Rust right now, but you know, it's all good. Anyways, you all have a great one. Till next time. See y'all.